Hello, this is Mrs. Collier. I'm going to read Big Ideas in Nature. If you have a hardback reading book, it starts on page 244. Now, this particular story is not in the teacher's edition or on the teacher's website, so I've had to go through as a student. So if you have trouble getting it pulled up, hopefully you can kind of watch how I get there. So I'm going into Tazewell County Public Schools. I'll go in as an employee. You'll go in as a student. And the stories during the review weeks, for whatever reason, are not as easily accessible. I think they're just for further understanding and knowledge, and that's why. I'm going to go in as student. Then instead of going down here to read like I normally would because it wasn't showing there for me, I go up here to resources and I go to literature anthology. Open this resource. Then, much like the social studies book, you have a table of contents here. And I go down to Unit 3, which is what we're on. And I go down to, I believe it's expository text. No, it's going to be under independent reading. And it's Big Ideas in Nature, which is an expository text story. So it was a little trickier to get to from my end. I'm not sure if it will be from your all's end. I just wanted to take the time to kind of show you how to get to it if it is harder for you all to get to. So, as you can tell, this story is going to relate to nature. It is going to have some scientific ideas. It's got beautiful pictures, as this book always has. But we're just going to take a look at it, and then you're going to do a scavenger hunt for it. So it says that this story is expository text. We have had some expository text lately. Expository texts are nonfiction, meaning they are not fake. They have a lot of facts and details. They explain things and give us information. So if I were to ask you the author's purpose of this story, it would be to give information. He is informing. You would be tempted to choose explain, but remember for explain, we are giving directions like a recipe or a how to make a birdhouse video or story, something of that nature. They're telling you how to do something and giving you steps, but information is giving you information, and that's what this story is doing. So something we will notice on each page is we'll have a picture of nature and it will say inspiration, and then we'll have a picture of whatever nature inspired and call it the idea. And there'll be a caption for each one. So let's go ahead and start reading. Sometimes a sticky situation can lead to a great invention. In the 1940s, George de Minstrel went for a walk with his dog. Along the way, George's pants and his dog's fur caught tiny seeds called burrs. George was curious. Why did the burrs stick so well? He looked closer. The burrs were covered in tiny hooks. George used this idea to invent a two-sided fastener. It had hooks on one side and loops on the other. Today, these hoop and loop fasteners are used on everything from shoes to spacesuits. And if we look at the picture here, this is what we would call Velcro that he has invented based on the burrs that he got on his clothes and on his dog's fur. And the caption says, observing how burrs stick to cloth and fur inspired one inventor to create a new fastener. Scroll on down and look at the bottom of the page. Those sticky burrs gave de Mestral a great idea. Nature provided a model that George could imitate. Copying or imitating designs from nature is called biomimicry. Bio means life and mimicry means to copy. From owls' sharp claws to elephants' bendy nose, Nature is full of models. We can learn from each one. So let's keep reading. Observing nature gives us ideas for new things. George de Mistral didn't set out on his walk thinking how he would create a new fastener, but by being curious and observant, he did just that. So I think that's really interesting how just a walk with his dog inspired him to not just say, oh, I've got to get these burrs off my clothes, how irritating, but instead to see the positive fact that they stuck to his clothes and that maybe he could make a fastener that would stick much the same way. Let's look under the heading Nature Did It First. Designers often start with a problem. They may look for solutions in the natural world. Nature has been making and testing designs for a long time. Nature often has the answers to questions people ask. More than 100 years ago, the Wright brothers, Orville and Wilbur, wondered how to fly. For an answer, they watched birds, the flying experts. Watching bird wings gave them ideas on how to design airplane wings. While bird wings are not identical to plane wings, they both can fly. The Wright brothers built an airplane in 1903. It was the first to lift up, 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 and away. So we have a vocabulary word, identical. It says, while bird wings are not identical to plane wings. So what do you think that means? Take a minute and think about it. Identical means to be exactly the same. They're not made exactly the same. They're just similar and they that's what identical means. Identical means exactly the same, but birds' wings and plane wings are not, but they can both fly. So let's take a look. We have inspiration being an eagle with its wings spread out. And we have idea, and here is a hand-drawn picture that they have copied of an attempt to make a wing for a flying machine. And it says, Leonardo da Vinci was an artist and inventor. He lived more than 400 years ago. He looked at birds' wings and then drew plans for many flying machines. So he was not the first person to fly, but even 300 years before the Wright brothers came up with an airplane that would fly, he also looked to birds' wings because he knew birds could fly. He knew that the concept worked, so he looked to them in ways to design a flying machine. And of course, the Wright brothers looked at them as well when they made a flying machine that actually would fly. Let's look at this page. So we have a picture of a fish, and it says inspiration. And then idea is a vehicle. So I would never have thought of a fish giving an idea for the shape of a car, but apparently it did. It says, watching fish gave car designers a new idea for a car's shape. Let's look at under the heading Smart Shapes. Fish and cars share a problem. It takes energy to move a fish through water and a car through air. Fish get energy from food. Cars get it from fuel. To create a new fuel-saving car, designers studied the shape of fish. They found that the box fish's square shape was streamlined. This means that the fish slips through the water without wasting energy. By making the new car's shape similar to that of the box fish, they created a car that saves gas. The car's frame is also similar to the fish's skeleton. The metal frame is thick in some places and thinner in others, just like the fish's bones. This saves on materials and puts strength where it is needed most. And we have the vocabulary word similar. So identical means exactly the same, and we have that on page 246. But similar just means that it's sort of the same. It's not identical. It's not going to be exactly the same. And if you will look at the fish and the vehicle, they are not exactly the same, but there are some things that you can see that are similar. You can see how the idea for this vehicle came from this fish. Let's turn the page. I'm going to read under the heading Energy Savers. Air conditioners keep buildings cool. The shape of a building can also help. In Africa, termites gave builders an example of a self-cooling structure. Holes at the bottom of termite mounds catch the wind. The hot air rises through tunnels and flows out the top. The termites designed an effective way to cool a structure. The builders borrowed their ideas. During the day, fans on the first floor blow cool air into the building. The air rises and flows through chimneys on the roof. This design saves money and energy. So we have two vocabulary words on this page. We have example, and often I will give you an example on a math page or possibly ABC order. I gave examples. It's showing you how to do something so then you know what yours should look like. So the termites and the way they built their mounds, and here's a termite mound, gave them the idea of something to kind of copy the formation of, or the way it was built as far as in design. Then we have effective, and it says the termites designed an effective way to cool a structure. So if something is effective, then it works well and it does what it's supposed to. So let's take a look. We have a termite mound for inspiration, and then we have the building in Africa where the idea is actually put into action. And it says, how is a termite mound like this building in Africa? They both need a way to stay cool. And you can see they said there were tunnels inside the termite mound, and it almost looks tunnel-like, the floors and things that they have in this building. So that's very interesting. Let's take a look at this page. For inspiration, that looks like a grasshopper. And then the idea, I'm not sure what that is. We'll have to read the caption. Grasshoppers and the robot Jawbot can both jump. So let's read about master movers. You can't travel to Mars, but a robot can. Robots can explore places that are not safe for people. Robots can't walk, but they still have to travel over dips and bumps. Sometimes they get stuck. Designers are working on a robot called Jawbot to fix the problem. The name Jawbot comes from the words jump and roll. The Jawbot can do both. The super spring of a grasshopper legs gave designers their idea. So I can see a little bit of similarity, but I'm going to imagine that where they have watched the grasshopper and them jump, that's how this Jawbot is able to jump and leap over obstacles in their way. Let's turn the page. Okay, and we're under the heading Tunnel Makers. More than 200 years ago, an engineer was trying to drill a tunnel under a river. But each attempt failed. The walls kept falling in. Then he saw how shipworms bored through wood. The animal uses a tough shield to drill. Then it builds a hard tube along the tunnel walls. What a great idea! The engineer copied the shipworm to build the Thames Tunnel. As he drilled, workers lined the tunnel walls with bricks. So that's a pretty interesting idea. So let's take a look here. So here's inspiration. So this is the shipworm. This is one of their tunnels. If you look, it's almost like you can see something white on the inside of their tunnels, which would have been the hard tube that they put in as they went through. And it says, shipworms and tunnel builders need a way to drill through wood or rock safely. So here is them actually drilling a tunnel. Let's take a look at this page. And now I've read the story, so I know, but if you have not read and you're just looking at this, it would be kind of hard to know exactly what animal this is, but this is our inspiration, and this is the idea. The caption says, Sticky gecko feet gave doctors an idea for a super sticky bandage. So I think that's very neat. And I think it's really neat what they do with it. So let's go ahead and read it. Mixing new materials. Tiny hairs on a gecko's foot help it climb walls. It can cling to ceilings too. Scientists studied gecko feet to create a bandage with bumps. The bandage is so sticky it can even attach wet surfaces like a human heart. So, this bandage they've made by looking at the gecko's feet for an idea is something that doctors can even use when they are working in the heart. So, that is very cool and awesome that they can use nature and come up with such helpful things for people. Let's continue reading. Now, when you look at this, you can tell this is an insect, but it's kind of hard to tell which insect it is, so we'll read. Here's our inspiration, our idea. Ideas from locusts are helping to design safer cars. So these are locusts, and this is cars that to me look like a traffic jam, but in a city that might be moving well. Let's read. Working together. Birds fly in flocks. Fish swim in schools. They do this without hitting one another. Cars move in large groups too, but they often crash. Today, car designers are learning from locusts. They study how the insects travel together safely. One day, you might drive a car that sees the cars around you. So, we already have some similar things to that. We have cars that have cameras on all sides. We have cars that can sense you're going to hit something and go ahead and put on the brakes. So that's similar, but they're saying that a lot of the idea for this type of invention in cars comes from locusts. Let's look on this page. It says learning from the experts. Biomimicry shows that ideas that work for nature can work for people too. It makes sense. Need a material that is strong and stretchy? Learning about spider silk would be a great place to begin. Spider silk is one of the strongest fibers in nature. It is as flexible as an elastic band and strong like steel. Need a type of glue that will harden in salt water? What do the sea creatures, barnacles, and mussels use to stick to rocks? Maybe nature already has a plan or recipe people can use. Observing how nature works also shows us ways to help the planet. Nature does not waste materials or energy, and natural designs do not pollute the air or water. Learning new things while protecting Earth's resources, that's an idea worth copying. So here we have the picture of a spider, and its spider web is inspiration. And then here's the idea, and it says this cloth was woven from silk that spiders used to spin webs. Now, when I read this story the first time, because this reading series is new to us this year, I thought, I can break a spider's web. Why is that so if it's strong as steel? And I discussed it with my family, and they mentioned that it's not often that we actually break the spider's web. We detach it from whatever it's attached to. And that made me think. And then I went on and did some Googling and looking for information. And we have to remember that steel that we are used to that is so strong is usually in large chunks. You know, you got like equivalent to a big board is what steel is usually formed into. So that's going to be very strong. And most of the time, the actual strings that a spider spins its web with are very, very thin. But if we were to put the spider web together and make it as thick, it would be as strong as steel. So that's not in the textbook, but it's something that got me thinking when I read that. So I thought it might get you guys to thinking that too, and maybe it would be useful to you. Go ahead and complete your scavenger hunt. Thank you.